Hello, my name is Rewan and I'm responsible for storage and database for our financial services institution in AWS. So for storage and database in AWS, we use AWS Amazon S3 bucket. We used also Amazon Elastic File Storage EFS, Amazon RDS Relational Database System, and Amazon DynamoDB. So in Amazon S3 bucket, it's an object storage device that you can store any object inside there, video, photo, logs, anything. It's scalable. It can shrink and expand as needed. Secure, high performance, and it's cost effective, as you only pay for what you use. We've also used Amazon EFS, Elastic File System. It's a serverless file system. No need for a server to run this file system. It's fully elastic that can also shrink and expand accordingly without any disruption to any operation or application that's running through this file system. It's also cost effective as you only pay for what you use. Another service that we use is Amazon Relational Database Service, RDS. It's very cost effective, it's also scalable, and it manages the common database administration tasks for you, like operating system installation, patching, recovery, or any administration task that needs to be done on the database so we can focus on the operational aspect. It supports different database instances and engines like MariaDB, SQL, Oracle, and much more. For our financial institution, we used MariaDB as engine. It has so many great features, but we mentioned that we mentioned the ones that we mentioned here are that this MariaDB engine uses a standard and popular query language, which is SQL. That's very popular and easy to use. It also runs on different operating systems and supports variety of programming languages, which makes it great to use for wide range of people. Lastly, we use Amazon DynamoDB. And Amazon DynamoDB features the one of the most important features that it's no SQL database. It's not relational. It's fast and predictable performance. It's scalable as the Amazon services. It offers on-demand backup, so you can back up pretty much whenever you need. It's also high availability and durability. Securing those services, we used Amazon Identity and Access Management Control, where we give roles to different users, and according to the roles, they can use the services. Implementing the multi-factor authentication for each account, doing network isolation using Amazon Virtual Private Cloud to make it private and not accessible by public or anyone else that doesn't have the credentials. We can also use the data encryption at rest and in transit using the Amazon KMS keys. Um, One of the features that Amazon DynamoDB offers is DynamoDB replication service role policy. It's permission policies that gives that can do different tasks according to the permission that's been given. And lastly, we can use secure protocols only. We can assign the service to use only secure protocols like SSL and TLS to secure our data during transit and makes it harder to manipulate. Going to our Amazon account, we're going to showcase our services in here. The first thing is the Amazon S3 bucket. We created a bucket. It's very straightforward, and then I'll show in a second. But in this bucket that I've created, I gave it a name, and then I've uploaded a text file just as a test to showcase how it works. Okay, we can also assign permissions using SELs or IAM. So inside the bucket, we can also give permission or block or unblock public access. We can manage the bucket and do any changes on by the during the time. Next, we have the elastic file system. I've created a file system here. I've called it Rawan. And in this file system, we can also see that we can change the access point. I've created an access point and attached it to this file system. We can add any policies to block or deny access. And we can also monitor the access system, the file system, sorry. We can also give it an IP address and security group accordingly to make it more secure. Next, we have our Amazon RDS using the DynamoDB. So I've created this, MariaDB. I've created this database with MariaDB engine, and it has 20 gigabyte. We gave it 20 gigabyte storage, allowed storage, and if needed, we can actually change that at any time. And it has maximum storage threshold with 1000 gigabyte. Last, we have the DynamoDB, where we create this database and then we create a table inside the database. And inside the table, you can change the properties of the table. We gave it a partition key that's a customer ID and the sort key as the name. We can change those and use whatever that's suitable for us. Thank you.
My name is Bianca, and today I will be presenting on access management for the cloud instance of our financial services organization. We have used AWS's Identity and Access Management Solution, or IAM. The purpose of IAM is to provide secure and controlled access to all the data and resources housed on our AWS instance. IAM enables us to manage user permissions and access privileges, and allows us to create and manage multiple users under a single instance. By using IAM, we can ensure that only authorized and authenticated users have access to maintain the security and integrity of our AWS infrastructure. As a start, we have created user groups for our employees and customers and added users within these groups so that they inherit specific IAM policies that have been attached to the groups. Within these entities, we are also able to grant and deny access to specific resources and define permissions for users based on their roles and responsibilities within the organization. The policies attached to these groups and users are guided by the least privilege principle. This means granting users the minimum level of access required to perform their necessary job tasks. Overall, the least privilege principle is a fundamental aspect of implementing strong security measures and maintaining the integrity of our financial organization's AWS environment. We have created the following groups in IAM. Firstly, we have administrators. We have department groups, including financial advisors and the support department. We have customer segments, including individual clients and institutional clients. And finally, we have vendors. Within these groups, we have attached policies that reflect the users' required resources and access needs for their specific job tasks and responsibilities. We have also added multi-factor authentication, or MFA, as a secondary component to secure our cloud environment. We believe MFA is an essential security measure to safeguard the sensitive financial data resources that will be used. MFA has been enabled for all internal employees. This is because they have an elevated level of access to sensitive financial data of the organization that we want to remain highly secured. And now onto our AWS instance. Under the IAM feature in AWS, you can see we have created 6 different user groups. In the administrators group, we have created Bill as a user, and here are his administration policy permissions. Similarly, we have created a financial advisors group and created 3 users in this group, including Dave, George, and Sarah. Their permissions include read-only access to RDS and S3, as well as billing access. Digging deeper into the RDS policy, it means that our financial advisors can perform tasks such as querying data, generating reports, and extracting information from databases without the ability to alter the data or perform any write operations. This policy ensures that the financial advisors can access the necessary information they need from databases for analysis or reporting while maintaining the integrity and security of the data stored within the RDS instances. As mentioned earlier, we have also enabled multi-factor authentication as an additional layer of security for all employees within the financial services organization. Google Authenticator has been chosen as the authentication device and will require 2 codes to be copied from the device to the AWS Cloud instance before they can access it.
Hello, my name is Adrian and I was responsible for the key management. So the 4 services that we will be using is AWS KMS, AWS Secrets Manager, AWS Cloud HSM, and AWS CloudWatch. So AWS Key Management Service, also known as KMS, will be in charge of the primary encryption and decryption involved in the environment. AWS Secrets Manager will provide additional layer of security by providing an additional layer of encryption. AWS Cloud HSM will be used to store sensitive keys such as master keys, and AWS CloudWatch will be used to monitor the environment for any abnormalities. So the first service that I'll be showcasing is AWS KMS, as it is relatively straightforward. So in order to create a key, for example a master key, you go create key and then configure the settings to how you would like it. So because a master key is being generated, it will be used to encrypt and decrypt. Make sure you provided a name, as well as the key administrative users. And then once that's all done, you review the settings and just click finish. Because I already created a master key, I will not be finishing this key. So generally for sensitive keys, you do want to store them in a HSM because they are more secure due to its dedicated security module. So in order to do that, you navigate over to AWS Cloud HSM Key Store and create a custom key store. However, before you can officially create a Cloud HSM key store, you will have to create a cluster over in Cloud HSM. So to do that, you click cluster, select the VPC, make sure this VPC is going to be the same one as the instance you are planning to use this HSM for. Configure its backup retention settings, tags, review, and when you're happy, just do create cluster. Because the generating cluster does take a while. I have already an example cluster 2 example cluster generators. So once your cluster has been generated, you will be asked to initialize your cluster. And to initialize your cluster, a HSM will be created in your designated zone depending on your subnet. And then next you will be required to sign a certificate and then upload it back up. So in order to sign the certificate, you will have to create a private key and a certificate authority. So once that's done, you will use the private key in order to sign the certificate and then upload this certificate back into the cluster in HSM. And then once that is done, you can connect this to your EC2 instance, and then you will be able to use this over in your key management service. So the next service that I'll be showcasing is AWS Secrets Manager, and this is used to and this will be great to store particularly sensitive keys. So for example, I will be using the ARN of this master key. So in order to store a new secret, you just click new secret. For cryptographic keys, it will be considered as another type of secret. Paste down your value, and then make sure for your encryption key, a different key is used for the encryption. And then when that is done, you can just click next, set up its name as well as a rotation. However, rotations can be set up later, and then review. Once you've looked through your settings and are happy with this, you can just click store. So for example here, this is a master secrets key. So your quote-unquote secret will be stored over in Secrets Manager, and you will be able to retrieve this secret value when you need it. So the last service that I'll be showcasing is CloudWatch, AWS CloudWatch, and this is responsible for detecting abnormalities within the environment, especially for KMS, HSM, and Secrets Manager in this situation. So in order to create an alarm, you just go to your alarms over in CloudWatch and create an alarm. You choose the metric in which you want to be recorded. So for example, in this case, it is a cluster. And then set the conditions in which you would want to have an alert. So in the example one that I already made, when there is activity within Cloud HSM, CloudWatch will be able to detect this activity and record this one. You will also be able to export this information and view it for yourself. Thank you.
Hi, my name is Marco, and today I'll be talking about network security and how I have implemented it to secure financial services. To start off, AWS offers many services to secure a network, including security groups, AWS Shield, network firewall, Route 53 resolver, subnets, access control lists, gateways, and route tables. Over here, we have our lists of virtual private clouds, one of which I have created to launch our network, and another one which has been created by default, and the IP address ranges are allocated to each cloud. Moving on, we have our security groups, which is essentially a stateful firewall for EC2 instances that monitors inbound and outbound network traffic. And because it is stateful, responses to a request from an instance inside are allowed regardless of inbound rules, and the same applies to responses to inbound traffic that are going outside, which are allowed regardless of outbound rules. And over here, we have our list of security groups, which monitors inbound and outbound network traffic for our financial hosts. Moving on, we have AWS Shield, which is a service that minimizes application latency and downtime by mitigating DDoS attacks and providing availability protection against layer 3 and layer 4 attacks or network and transport layer attacks. AWS Shield is activated by default if you use the standard version. However, if you think the protection isn't enough, you can upgrade to advanced. But I believe the protection offered by standard is secure enough for the network. Moving on, we have AWS Network Firewall, which provides intrusion prevention and web filtering by protecting our virtual private clouds through stateful or stateless inspection. And it also allows users to define rules that control network traffic, including inspection and filtering. To create a network firewall, there are many things that need to be done. First, you need to create a rule group, either stateful or stateless. Over here, I've created a stateless rule group. And after you create the rule group, you create a firewall policy and assign that rule group to the firewall policy. And then after you create the firewall policy, you create a firewall and then you allocate the firewall policy to that firewall. Moving on, we have Route 53 resolver, which mitigates malicious DNS queries during DNS resolution. And it does so by connecting to our virtual private clouds through VPC plus 2 IP addresses within each availability zone. And it utilizes inbound and outbound endpoints to enable DNS queries between our virtual private cloud and on-premises network. As you can see here, we have Route 53 resolver enabled on our virtual private cloud with rules and one outbound and one inbound endpoint. Moving on, we have subnets, which are logically isolated spaces within an IP address range in our virtual private cloud. They can either be public, which connects to an internet gateway, or private, which is more secure and it doesn't directly connect to the internet, but it requires a NAT gateway. And each subnet must exist entirely within one availability zone, so it's ideal to put them in different availability zones for business continuity in case an availability zone fails. Over here, we have our lists of private and public subnets and the IP address range allocated to each subnet. Moving on, we have our access control lists, which are stateless protection for our subnets that allows and denies inbound or outbound traffic, and because it is stateless, responses to requests are not automatically allowed. As you can see here, we have our access control list created and 6 of our subnets associated with it. And moving on, we have our internet gateway, which allows communication between the virtual private cloud and internet, and it can connect to hosts in our public subnet as long as they each have an IP address. And as you can see here, we have one internet gateway created for our virtual private cloud. And moving on, we have a NAT gateway, which enables one-way communication from our VPC to the internet, and it connects our private subnet hosts to the internet, but external services cannot access the private hosts. A NAT gateway can either be public, which provides one-way connection to the internet, or it can be private, which provides interconnectivity between our virtual private cloud and other virtual private clouds or our on-premises network. As you can see here, we have one NAT gateway for each availability zone. And finally, we have our route table, which stores IP addressing rules to redirect network traffic from our subnets or from our network gateway. And they can either be we can have a main route table, which automatically comes with our VPC, or it can be custom. We can have our gateway route table, and we can have subnets associated with each route table. Also, can have route tables associated with each subnet. And as you can see here, we have our route tables for each subnet.